Hello and welcome to this new video. Today, as part of my training, we're going to solve a very complex case which is called Excelopolis. If I remember right, during the original competition live solve of this case, the competitors struggled a lot to even solve probably level one of this. Um, this is not the first time I'm going to solve this, but a long time has passed, so I hope this will be a significant attempt. But let's go straight into it. So you basically have this map um, and the tribe basically, where you can see here the map is based on three different colors, so blue, green, and white. And basically, the numbers you see in it are the value of production of the particular cell because you need to cultivate the food basically to grow your tribe. And depending on the size of your population, you could use first of all the blue area, then you can expand to the green one when your population grows at 7 people or more, and then the white area when you have the population of 17 or more. On top of that, we can say that the tribe is founded at the beginning of year one. Initial size of your city's population is 1 unit. The land around Excelopolis is represented by the cells. Okay, the city itself is located on cell D4, which is this one. Every unit of population can cultivate one cell of land around the city. So initially, your people will be cultivating only one cell. Different cells have different fertility. Okay, you will be using the most fertile cells first. You can cultivate land that is more than 3 cells away from the city. So we have your maximum of 49 cells which can be used. Um, okay, then you have the rules for the expansion. Food storage, every year 1 unit of your population eats 2 units of food. Assuming they do it at the end of the year and don't need to eat during the year, the remaining units of food produced during the year are added to the food stock in a warehouse. If at the end of a year the amount of food in the warehouse is 10x the number of population units or more, two things happen. At the beginning of the next year, your population grows by one, and you can cultivate one extra cell of land. The 10x units of food stored in the warehouse are used for growth, and the warehouse now is empty or almost empty. So level one, consider only the cells that are adjacent to Excelopolis. So basically, you're provided these kind of data sets, and basically for level one, you have only C3, C4, C5, D3, D45, E3, E45, which are basically the blue cells. So without any kind of doubt, I will use a separate solver. I think it's called sample one if I spotted this right. So let's X look up as usual the data. Okay, and then I have cells F2BB, and that's okay. Then I think I also want this. Okay, so the first thing, sorry, I'm going to need is to understand what is the distance from the city. In this case, actually, I don't need it because the request is how many years it will take to grow its population to 10 units. Um, but anyway, I will not need to consider the second tier of cells around the city, so I can ignore for now the expansion logic basically. So let's say we have let x being this. I want to transpose filter x with the x is not 0. So basically those should be the fertilities of my first example. We should have three values times 3, so 9, yes. And we can also say sort this store this in a descending way. Okay, because I'm going to cultivate the most fertile first. So, having said that, I will say that population is one, then I have um, the consumption, let's say the production. Production will start here. Um, then I have the consumption, which is population times 2, if I remember right. Yes. It's for the price either near another for stock in a warehouse. So I have stock, which is production minus consumption, and will be this minus, sorry, mm, this plus all this stuff. Um, check. So if this greater than or equal to 10 times the population, we'll have one otherwise zero. So when okay, at the end of the year, it's 10x the current number of population units. The beginning of this year, population grows by one. So this will be this plus if this equals one, otherwise zero. We can also say this plus this, basically. Uh, and it means I've used 10x the level of stock. Uh, so my next term will be that previously plus the production minus the consumption minus check times 10 uh, times this. Not sure. Consumption will remain the same. Actually, production is not correct because what I need to do is basically sum um, this depending on the number of units of population they have. So the most appropriate way to do this will probably be a sum of take of this lock, and I will take exactly the number of population units I have. Yes, okay. And basically that's it. So let's check. So year one, if one person produces five, consumes two, I accumulate three, then another three, then another three, then I get to 12. It's time to grow. So basically, I burn 10 here, and I remain with two. Then I can cultivate 9, which is 5 plus 4. Okay, I consume 4, so stock is 5 plus 2 with 7. Seems right to me. Let's see. Need to grow to. That's interesting. This is going on. Okay. Um, how many years it will take to grow to 10 units? Uh, 55. Actually, it's 54, so it's probably needed a minus one. Anyway, I will drag this down quite a bit in order to be sure this is working properly. So match 10 people here, 0 minus 1. So I have 54. Uh, let's scale this. So sequence of 100, like this. And I have 15, which is sums up to 878. Let's check here. Yes. So matches 93, 44, 63. Yes. Okay. So this is correct. Now let's go to level 2. How many years will it take to Excelopolis to grow its population to 26 units? This time, when I go above basically 7 people, I will need to consider also the cells at distance 2. So what I will need to do is to introduce the distance concept. Uh, and to do this, probably I could say we have, okay, so left of this and right of this. Okay. Um, we have D4, which is our city location. Yes. So the distance from D4 will be the minimum of apps of code of this minus code of this and apps this minus this lock. Let's see. So my D4 will be zero distance. D3. No, it's clearly not at zero distance, so it's the max. It's the max, I think, not the min. For example, G6 makes sense. F2 makes sense. Okay, makes sense to me. So in this case, basically, this thing here um, will be not when x equals 0, but let's introduce y or this, even better, which is basically this. Okay, and then we sort transpose filter x where this is minus than or equal 1. So nothing is changing. I've just made this dynamic. And so this will be D1, D2, and D3. So D2 will be exactly the same, uh, except that it needs to be here. Okay, and D2 actually is minus equal to. Um, okay, actually sample 2, and I have 25 cells, 7 or more. Okay, we'll not need to expand to level to the distance 3. So in this case, the production will be um, so in this case actually I'm sorting together basically distance 1 and distance 2, but I think this will be right considering that. Please also note that you can use the cells in the outer circle only after Excelopolis reaches at least 7 units of population. Um, my question is, am I allowed to basically move the production immediately to more fertile cells? Potentially the answer is yes, because in level 4 you're told after expanding to population size 7 or 17, you are not allowed to move production from less fertile to more fertile. So you should keep it. So in this case, I'm assuming I can switch. So in this case, it will be similar, but instead of saying take this, I will say take if this is less than 7. Yes, that one. Otherwise, I will take this, close the if lock. So basically, the question is how many years will it take Excelopolis to grow its population to 26 units? Uh, Year sequence of, I don't know, 300, because I see 184 84 in the example. Uh, let's update. The question is 26. Need to expand the range. 184. It seems right. So 16 to 30. Let's update. Actually, we have some problems here. Example 22. No, it's not enough. Let's be conservative. Let's say 500. And let's go down a lot. Okay, so 16 to 30 sums up to 3111. Let's see. And actually is correct. So level 2 is done. Uh, Level 3 says how many years will it take to Excelopolis to grow its population to 50 units, and actually introduces all the cells. So this might be as long as 1,500 years. That's interesting. So let's say this. Okay. Let's expand our match. Okay. So in this case, I will need also distance 3, which is basically everything. Okay. Actually, it will be sample 3. Okay. So sample 3 is done. It's actually 49 cells. Mm, is it only a matter of managing this? So ifs, this is 7, otherwise this is less than 17. Uh, Otherwise, I will just have this. Don't remember the, yes, 17 or more, so less than 17 should be right. Uh, okay, and I'm required to check whether the population, when the population grows to 50 units, 50 units, 448, yes, 30, 31 to 50. Let's update. 31 to 50 sums up to 13,041, and that's correct. So checks out completely. Okay, so now level 4 asks how many years will it take Excelopolis to grow its population to 50 units? Land plot change not possible. So after expanding population site 7 or 17, you're not allowed to move production from less fertile to more fertile. If a cell is previously used in a production, you should keep using it even if other cells are more fertile. So, okay. Basically, what this means is I will start, of course, from here, and those can be sorted, and that's okay. And so, if I'm below 7 units, I will lose exactly those. Exactly when I grow to 7, I can introduce those one, and I can basically mix up the remaining basically cells of distance 1 with those, so I can sort that mixed component. And same thing will be true when I can switch to distance 3. So what is probably best to do is build another set of distances. Um, why not locking this? Will be much easier. So this will be my distance one um, scope. When I go to distance two, I will have um, basically I will have a V stack of six of those, okay, and then I will have a sort of, let's say, let X be the V stack of these, okay, uh, and this, um, and then I'm going to sort this, sort X minus 1. Let's see. So basically, until 6, I will have the same, and then I started going with those, and I will basically mix up. So here starts my new one, which is 28 big. That should be this, which is 25 plus exactly this. Yes, because 6 I've already used in the previous iteration. For distance 3, for distance 3, I will need to apply the same logic. Uh, what if I just take the first 16 here and then I do the exact same logic? So let's see. Um, in this case, we'll do something like this. So I will need 16 of this. And so this will take the remaining piece. No, actually it's not correct. No, this is not correct, even for distance 2, because here I'm double counting this basically because I've already used those. So what I will need to do is, first of all, I mean, the logic is similar, but not exactly the same. So this will be distance 1. Distance 2 will be equal to 2, and that's it. And distance 3 will be equal to 3, and that's it. Okay. Then this will be, okay. This will be, mm, this will be like this because I need to take the first 6, then I can mix up what is actually in distance 2, exactly distance 2, and what was remaining from distance 1. And distance 3, at this point, will be 16 available cells from distance 1. The remaining of this mixed with the exactly distance 3 cells. At least I hope so. So this is 49 long, this is 25, okay. And then let's hope this works. Basically, I will need to change this with this. Lock. I will need to change this with this lock, and I will need to change this with this lock. Okay. I'm required to understand to 50 units. So this and actually checks out. It will be probably my best attempt at Excelopolis. So 51 to 70 sums up to 12,835, which actually is correct. So great. I have level 1 to 4 in 25 minutes. Level 5 land plot degradation active. How many units of population will Excelopolis have after 500 years? Basically, consider all the cells you're not locked in with less fertile cells, but land degradation should be factored in. If a cell is used for production for 10 consecutive years, its fertility lowers by 1 unit, 20 years 2 units, and so on. If a cell is not used for at least a year, its fertility resets to the initial value. If a cell fertility drops to 0, it should not be used next year so that its fertility resets. Regardless of degradation, you have to use all your population on the most fertile cells, even if it might slow down the growth in future years. However, you have several cells with similar fertility, but not enough people to work on all of them. You should leave in uncultivated those cells that will refresh to higher amounts. Guys, this is probably a mess. My perception is that I will need to model separately each potential cell. So basically, my table here will need to expand to consider all the cells, see whether those have been used, what is the fertility value, and then make the logic from that. I think I will stop this video now to make it a little bit short and address this level 5 in a separate one. So thanks very much for watching until now and see you in the next video. Bye.